Alright, in this video we're going to continue the work on our configuration system. In the last video we had set up the structural foundation for our config class, we had laid out the methods, and in this video we're going to go back in a second pass and apply the actual method functionality.
That's right, with each one of these methods we set up, we kind of told you generally what each one was intended to do, and now we're going to go through and code in all that functionality.
Alright, so beginning at the top here, we have our set config file method. And again, this simply needs to link up and look at the real incoming XML file. And this is very simple. All we need to do is tell our existing XML config, our XML document instance, we just need to tell it to load a file. So we'll call .load,
file name,
and we'll pass in file name. As simple as that. So that will get us associated with this incoming file name. It'll load up that file, parse it, and it will be ready to go, ready to be navigated via this XML document instance.
Cool.
So we can move on.
That's probably the easiest one, isn't it?
Yes, it is.
Yeah, figures.
Alright, so next up we've got load options. And of course at this point in time we only have 3 actual options, so we're going to need to code in the necessary method calls to get these values loaded. We'll begin with screenResX. So that we'll say that the screenResX field is going to be set to the value, and we're going to have a few nested method calls here because, of course, we need to start with this guy. This XML config is kind of our root link to our real XML configuration.
He gives us access to that config file.
Exactly, but he's going to be talking about stuff in terms of nodes, which is convenient. The node instance has a lot of useful things, but there's a possibility that if we address this guy and tell him to load up a node that doesn't exist, he's going to give us back a null.
Right.
And so there's nothing we can do about that.
Which is why we set up all these little parse deals, like the parse methods that we set up earlier.
Right, and we're also going to need to check for nulls as we load them. Now it would be very inconvenient if for every single field we had to make an if statement that said, did the load work? Do we have a node? And then for the 20th field, did we have a node? And so on and so forth. So we're going to have a series of methods that will sort all of the stuff out and make sure that by the time we look at the field, we have something. Maybe it's a default value to prevent errors, but it's at least something that can be stored.
Now, screen resolution X was an integer, right?
That's correct.
So we should be using the parseInt method.
Exactly. We're going to need to take whatever value we do end up coming back with whatever series of calls, and it's going to be will need to be converted to an integer to be stored.
I do it all the time. You get like 5 wires crossed over each other.
Oh yeah, it's good stuff. So, since we'll need to look at an int, we'll call our brand new and yet to be coded parseInt method. ParseInt is going to need to take in a string, and to gather that string we're going to utilize our, once again, yet to be coded, getNodeValue. So we'll make a call to getNodeValue. We'll need to pass in the XML document that we're currently using, which is XML-config, and we will also pass in the path to the node that we are looking for. Now, we'll look back to our config XML just to make sure that we know what it is we're trying to navigate to. We're going to navigate in an absolute fashion, meaning we'll start at the very root of the XML file. The root node, of course, is config, so we'll specify that first. Then we'll specify options underneath config, and finally we'll specify screenResX is the actual node that we're trying to load.
Okay.
So back here in the form of a path, this is actually going to be /config /options /screenResX. And that takes care of our path. So we'll finish off this parenthesis, and that takes care of our getNodeValue function. One more closing parenthesis will take us back to parseInt, and then we can terminate the statement.
Okay.
So it's basically like, in a nutshell, load this node using this XML document instance, the result of which will be handled inside of getNodeValue. We'll be returning a string from getNodeValue, and we'll be converting that into an integer using parseInt, finally to be stored in screenResX.
Right, which is why we went ahead and gave you the skinny on what each one of these methods is going to be doing while we type them out. Because they kind of all have to be interdependent upon one another.
Exactly. All these have been chained together so that all the repetitive stuff we have to do can be done as little as possible. Alright, for the remaining 2 values for screenResY and startup full screen, we'll be using a similar series of method calls. So I'm going to copy and paste to duplicate this line. And we can now address screenResY, which involves changing X to Y on both the field name and the target node that we're looking at. Everything else will remain the same. We're still looking for an integer to be stored in screen res y.
Right.
All right, now we can address our startup full screen. And we'll just drop that in with IntelliSense. Startup full screen is a boolean, so whatever value we end up getting back, we're going to parse to a bool. And the target node we're looking at in this case is startup full screen. And that should take care of our final call.
Now, did you need a capital startup on that last one?
Looking at it, so far
I honestly can't remember is the only reason I'm bringing it up.
the naming scheme we've got going so far is actually lowercase on the beginning on each in the config file.
Okay.
And this just made it ended up making a nice standard in the end.
Yeah, I just couldn't remember, so I thought I'd ask.
But yeah, always good to check, because of course these names are going to need to tie exactly to your config XML file. So
Right.
this would be one key place to look for problems if things aren't loading. Make sure that all of these names line up with all of these names.
All right, so does that take care of load options?
That it does. That's all three fields addressed, and now we can turn our attention to get node value. All right. We're actually going to leave the return statement in place and use that only if accessing a specific node does not work. So basically, we're going to have some code. It should get a node, read out its value out of that attribute, and then return it. If that fails to happen, then we'll fall back on our original return, which will be an empty string.
This is really all about some error checking.
Yes, this is the primary function here. Of course, really the core of accessing this attribute inside of the config file is going to happen here. But in addition to that, we're also going to handle the case where we addressed an invalid node.
Gotcha.
Now, in order to look at these nodes, we're actually going to make a local variable here of type XML node, so that we can store whatever result comes back out of the XML document. So we'll say XML node, and we'll call that node. And now we will run a method that is contained within the XML document type that should look up a specific node, and if it exists, return a node instance.
Okay.
So we'll use, let's see, looking here, we're getting an XML document passed into us, so we'll use that XML document, and we'll use a method called select single node. Select single node, and we need to take in a string for what is being described here as the XPath. Now, when working with XPath, this can get very in-depth. There are many very powerful features provided by XPath that can give you almost database-like functionality. Mm-hmm. We're not going to address this in the terms of the drum game. Here we're just looking at getting direct and simple access to individual values.
Well, that same information that we coded in earlier in load options.
And that's exactly the way that this call is set up. Since we're passing a node path, we're just going to pass that path along. So these paths that are getting passed here, that is one of the ways that you can use XPath, is to directly address a single node. And so we'll simply pass that along.
On that note, this also reflects what Logan was discussing earlier, how this is kind of like a soft get node value system, where the XML document.select single node command method that we're calling on here, this is what you generally use to do it, but the problem with this is this can return a null if you ask for something that doesn't exist.
Exactly, and the fact that it returns a null is not necessarily a problem. It's just that there is some checks we'll have to do ourselves to handle that.
It could be a problem, so we're going to take it and address it right here inside of this method.
Exactly, we'll address it once here in this method instead of again and again for different fields. All right, now that we have run our select single node and we either do or don't have a node, at this point we need to decide, because if we do or don't have a node, we need different things to happen. So we'll say that if node is not equal to null, meaning we did...
Yeah, if there's something there.
If we did successfully get a node instance back, then we'll need to return that value contained within. So we'll directly run a return right here. And we'll say that we need to return node dot... What precisely? Well, we need to return the attribute that was part of the node. So a quick review in the XML file. We consider this screen res x to be a node. We consider the value equals, or rather value itself, to be an attribute. So we actually need to look into the attributes of this node, look for an attribute named a value, and return whatever is contained within it.
Easy enough. So
what we're looking for here is node.attributes. So to look through all of our attributes, more specifically address an attribute by name called value. So we'll use square brackets in the string value in order to describe the node that we want. And this will return an individual XML attribute. The attribute itself has a few properties here. And what we're actually looking for is value. So the value of the returned attribute given this name.
Okay, makes sense.
Now I know the syntax can look a little bit confusing here since we're using an attribute name of value, and then we're getting the value of that attribute, so we're getting the value of value.
Right.
But again, this is just because we happen to name this value. We could have named it something like data member equals. But again, this is just simply matching the name from value here as the attribute, getting that attribute's value, and returning that.
Makes perfect sense. So if we made it this far, then we're basically done at this point.
Exactly. At this point, we will return whatever that value is, and that's it for method execution here.
But what if it is a null?
Well, if it is a null, then we want to indicate, I mean, at this point, we could actually leave the method as it is, and this will accomplish the function of soft node value loading.
Yeah.
The problem here is if we don't say anything when there's an invalid value given, we'll be given no indication as to why values might not be loading.
Gotcha.
So what we're going to do is in the case that we couldn't get a node, we're going to use the log inside of the game to say that there was a problem.
Nice.
So that way we do get an indication of the fact that something was done wrong. We just get it in a way that doesn't crash the game. So we will drop in an else clause to our if statement. And if we happened to not have a node, we'll address our log and we will write out a line. And let's put some formatting together. Let's say that in the case of a problem, we'll say that there was no option named, and then we'll specify element 0. We'll end off the string and then pass in the actual argument itself, which will be the full node path.
Now, I know it's just a coding style thing, but you don't really need the else in there, do you? Because, I mean, technically, if you find that it's not a null, then you're going to return and you're done at that point. So the only time you'd get down here is if you have found that it is null. And so you should just be able to write and then return.
That's true. Yeah, you could move this log on.
Yeah, like I said, it's totally stylistic. I'm just throwing that out there for you logic bugs out there who like picking on problems like that.
Oh yeah, absolutely. We could certainly set this up where we don't even need the else. We could do the opposite, where we could put everything inside the if and else.
Right.
Though we would have to deal with making sure we satisfy the requirement to return a string.
I like it just like it is. I just thought I'd throw that out there.
So with this, this now takes care of our getNodeValue method. So from here, we can move on to all of our parsing routines.
These are all probably going to be fairly repetitive.
Actually, yes. And a matter of fact, most of them are going to be utilizing existing conversion functionality. There are already facilities to allow you to convert things inside of .NET from strings to any given number of types.
Then why use the methods that we've set up?
Once again, to give a more soft and log-friendly method of loading.
It gives us the ability to log stuff.
These conversion methods we're going to use generally throw exceptions when something happens that they don't like.
Okay.
And in this case, we're going to handle these exceptions ourselves and express them using the log rather than crashing the game.
Very cool.
So we'll begin inside of parsable with a try statement. And inside of this try statement, what we're going to attempt to do is to convert the incoming string value to a Boolean. So we can look into the convert class, and we can convert to Boolean a given value. So we've got many overloads here for many different types, but we're actually looking for the value coming in. So again, we're just specifying this parameter, happens to be a string, and if we can look through these and find that it is actually it's overload number 13, which takes in string.
Okay.
Just for
in case you need to know.
Now, if this conversion did not work, then convert is going to throw an exception, so we'll put together a catch statement to allow us to handle the exception. So if something did go wrong, then we're going to simply write out to our log using log.writeLine. We'll set up the error message we would like to put together. we'll do something to make this a little bit easier to see. We'll throw a few greater than signs, and then we'll say that there was an exception when converting a given value. Let's specify argument 0 to a bool. And we could go so far as to say that we are returning false. Depending on how much screen space you end up having in the log on your side, you might want to take that out altogether. But again, just give some type of intelligible message as a result of this error.
No, we're not using word wrap on our log, are we?
We are not. So if we happen to overflow the log, it'll simply be clipped off screen.
Okay.
All right, that should take care of the error message, and we'll leave the default return of false, once again following the same methodology as here. Is if we somehow manage to make it all the way down here, then there's a problem, so we're just returning false.
Works for me.
All right, moving on. We can do much of the same thing for our parse int method. As a matter of fact, so much the same that I'm going to begin by copying our entire try-catch statement. Jumping down here to parse int, jump in a line right before return 0, and paste all of this in.
Just swap out your conversion method?
Yep, all we're going to do is change convert to int, let's see, to int 32. And if that failed, we'll simply make our error message say that we were trying to convert to int. So exactly the same scenario, just setting up some error checking in case convert.toInt32 failed.
Except if you want to be all chatty about it, you wouldn't say return false, you'd say return 0 instead.
Exactly.
On your log.
And really that was just leveraging the fact that...
No, I mean up here on your log statement, because you're saying return
I
false.
See. Yes, I knew being verbose in those error messages was going to come back. It was going to come back to me somehow.
Yeah. The more you talk, the more trouble you get yourself into.
And if we're being... Let's see.
Story of my life, really.
We could even put this and say returning instead of return.
I wouldn't worry too much about being grammatically correct.
Okay.
You're limited on space anyway.
All right.
And since the debug method is something only the programmer's going to use, they're going to remember those.
Exactly. So moving on, we have parse float. So we'll do the same thing. I believe I still have that whole method on the clipboard, so we'll paste it in. Actually, I don't, so... Again,
that's my fault.
Just to rephrase, we'll grab our try, catch, block. We'll go down now to parse float. We'll paste in the entire try, catch statement, and the conversion we're going to attempt is to... Let's see here. To single. And this is, of course, just single precision as opposed to double precision,
right.
which is actually the float type inside of C#. So parse float, we're returning a float, doing our conversion, and then we'll change our error message slightly to say that there was an exception, converting to float.
And then we're going to return 0 instead of false.
Exactly.
Check your comment.
And, yes, returning 0. Excellent.
I'm here for you, man.
All right. Now we can turn our attention to parse vector 2.
Now, this is where it starts to get a little complicated.
Yeah, this is where it gets interesting, because we are going to do a little bit of parsing ourselves. We're still going to be leveraging some of the existing conversion functionality. But looking at vector 2, the way we're going to store these is simply by saying that we'll have, let me throw in a comment here, the value we would be looking for would be something like 5, 2,
okay.
Or 1.56, 3.876.
X and Y coordinates.
But the idea here is that in each of these cases we're going to be separating by a comma. Okay. So since these are, as a matter of fact, let me drop out the spaces. The way we'll actually store these in the config file is as such. Two numbers separated by a comma.
Now looking ahead, we're throwing these methods in here just as a way so that we have access to them later. Now, do you already have something in mind that is going to utilize vector 2 information?
A lot of the style configuration, a lot of the positioning of screen elements are going to be expressed in terms of vector 2.
Now, that being said, are you going to be using just integer values for pixel locations?
In that case, possibly.
Okay.
The nice thing about Vector 2 is that
Just kinda leaving it general.
it kind of leaves your options open. There's obviously no problem in storing integer values inside of a float.
Right.
And that way we don't have to get into very fine-grained specifics.
Just making sure that everybody's on the level.
Now, that is an interesting point. If you're working as part of a team, putting together any given project, it may be worthwhile for one of the members of the team to add an entire suite of parse methods
Right.
to get things like maybe a point type if you specifically wanted to restrict people to integer values, or go through any number of the given types available in .NET inside of XNA.
Right.
In our case, we're using Vector 2 just because it nicely fits multiple scenarios. All right, so with this in mind, the idea that we're going to need to take two numerical values, and also keep in mind that these values are going to be coming in as strings. So it's actually going to be up to us to break the string apart on any given comma and then read the individual numbers out of it. So let's put together a quick routine to do just that. What we're going to do is we'll utilize the string split method. And of course, value coming in as a string, we could do something like value.split. And into split, we could say maybe split on an individual character. So put single quotes and drop in a comma. Now, of course, split is going to be sending back out a string array. So to store this, what we'll do is we'll make a local string array variable that we will call args. So these are, well, we'll just say that these are arguments coming in.
Sure.
And that will be equal to value.split. And that way, we'll take the string and we'll get two new strings out of it. We'll get 5 and then 2, or 1.5 and so on, and 3.8 and so on.
Exactly, stored as different index values inside your array.
So that way we can address the values individually and run conversions on them.
Cool.
So we'll make a few intermediate variables before we actually assemble a vector 2 to be returned. We'll make a float variable called x, and that will be equal to convert dot toFloat, or excuse me, toSingle in this case, since we really have to address these types in terms of actual CLR types here.
Sure.
The individual type system. So we'll run convert to single from our given value, and we'll turn around and duplicate this line so that we can make a variable called y. Or excuse me, and in the case of value, looking at this, naturally we're not going to throw the entire thing in. Really what we want for each specific one is to look at an individual argument by index. So we'll look at args sub 0
And then
for
arg
x.
sub 1, right?
Exactly, args sub 1, and we'll store those. So we go from string to multiple strings, from each element string into an actual float. Then we can assemble a vector 2. So we can say, actually we'll do this on the fly. We'll actually put together our return statement. So we'll return a new vector 2, and we'll specify x and y.
Easy enough. So you're taking in some data, you're ripping it apart, storing what you find inside an array, taking that array apart, putting it in individual variables, and then returning that.
And then packaging it all back up into a vector 2 to return it.
Do-do-do-do.
Now, of course, with all of these, since we're running conversions and doing some string operations, there's, of course, the possibility for exceptions. So we'll drop all of this in a try except block. So
I guess at this point you probably nuke out those comments.
yeah, we'll worry about actually putting some values into effect once we have the config system running and can test them.
Right.
So we'll just chunk everything into one try statement. So if anything blows up along the way, all of this will get considered.
Okay.
And then for our catch, we'll simply do a similar error message. So I'm going to grab one of our existing log.writeLine statements and drop that in place. Only we'll say that there was an error in converting given element to vector 2. And we'll say what our default return type is going to be. So we'll indicate that we're going to be returning vector 2.0. And that should take care of parse vector 2.
Okay, cool.
Now we have,
Which leaves us with, what, parse color?
yep, one left. Inside of parse color, the first thing I'm going to do is change the default return color to red, something a little bit more conspicuous.
Okay.
So right off the bat, if something bad happens, we can't parse the color, we'll just return red. So if we see any blaring red colors inside the game, that would be a simple visual indicator that something was messed up in the parsing phase.
Which is a good indication to your graphics designer not to use red, at least full red, for anything important.
Or on the other side of that, if your game is going to feature a lot of the color red, then probably pick some other uncommon color.
Like green or blue or something else.
All right. Now we have a very similar scenario here where we're going to store a color in terms of comma-separated numbers. For example, we would say white would be 255, 255, 255. Or we could have some variant of any 3 digits, like so on. So we'll use a similar approach. We'll use string.split, but we'll be reading out more elements. We're also going to allow for alpha information to be specified. So that's where we would add an additional number, so possibly add and say that we're going to have an alpha value of 64. So we're going to need a little bit of code to detect whether we had 3 or 4 elements.
You got me really curious. I never actually punched in a color value that was over 255. What happens?
Oh, it's just it'll wrap back around.
That's what I thought. Okay.
This is just for theoretical
I know
purposes.
that's branching way off topic, and I should be smacked for it. But
So
you punched in the number, and it made me curious.
Yeah. So to make this make sense in terms of real actual colors, it
You
would
don't
look
have
something
to.
more.
I get the idea. We're going to take in some color value, which will come in the form of 3 numbers that are separated. Or I'm sorry, 4 numbers separated by comma because it's RGBA.
Right. But the idea is here we want to make this method a little bit adaptable to where we don't have to specify alpha. We'll say that alpha will default to completely opaque.
Ah, okay.
And
Yeah, that makes sense.
And in the case that we give a 4th value, then we'll consider that value and use it for the alpha information. All right, so to put this together, we'll begin with the same call we used to split up our vector2 arguments. We'll make a string array, we'll call this args, and we'll set it equal to value.split. And we'll split on any comma character. Then we'll turn around and we'll make a series of values that we can use to put together a color. Now, of course, when we make a new color, we'll specify each individual channel as a byte. So we'll make a bunch of byte local variables here. We'll begin with the red channel. Say byte r is equal to, and now we need to convert the very first argument. So like you're saying, this will be red, let's see here, red, green, blue, alpha. So red will be convert dot 2byte, and we'll specify the very first argument. So args sub 0, and let's see, and we can wrap that off here, just like we did in the vector2.
Okay.
All right, moving on, we now need green, blue, and alpha, so I'll simply duplicate this line 3 additional times, and we will drop in our green, blue, and alpha, so G, B, and A to represent the different channels, and we'll specify elements 1, 2, and 3. Now, of course, this alpha is a little bit more interesting. The idea is that we want to allow a 3-value number to work.
Right, without breaking something.
So we actually need to check before we run this conversion. What we'll do is we'll actually drop in an if statement, and we'll say that if args.length is greater than 3, then naturally we'll have a 3rd, or rather 4th, element.
Gotcha.
Now, as far as the color itself, we do still want to have a scenario where it will default. So let's actually define the A variable outside of the if statement and just set it to 255.
Makes sense.
So that will be our default value. Then if we do happen to have an alpha specified, then we convert it and store it.
Perfect.
So now that we have the individual values for a color, we can assemble that color. So we'll say that at this point we'll go ahead and return, and we'll return a new color. And that color will be specified with red, green, blue, and alpha.
Too easy.
And then, of course, we need to put in the necessary exception handling. So let's jump back up to the top. Let's wipe out our example comments and put together a try except statement. So once again, the try statement will go around the entire conversion code here, right up until our return. And then we'll put together our catch. And inside of catch, we need to grab a error message. So I'm going to just duplicate one of the ones above. Really quick, we can jump in here, say that we were trying to convert to a color, and it failed, so we're going to be returning the color, what are we returning? Red?
Red. Yeah.
So yeah, return red. Simple enough.
Yeah.
Now, with that, we have all of our values addressed. We have an intelligible error message. So that really takes care of all of our conversion methods.
Okay.
I'm going to build briefly just to make sure that there's no basic syntax errors throughout our config class. And now, at last, it's ready to be put into use.
All right. So are we going to take care of that in the next video?
Yeah, this would be a good point to break it off. So now, at this point, we have our config class ready to go. So we'll pick back up here in the next video.
Sounds good.